In the last video, we talked about a situation in which a sample of 100 people is randomly selected from a population, and a sample mean is calculated, and we wanted to know the probability of the sample mean coming out to 38 or less in that situation. I said that in that type of a situation, the z-table can be used to find the answer if the sampling distribution is normal. And I said that in the next video, I would explain how we would know if the sampling distribution is normal in that type of a situation. So that's what I'll explain right now. When a sample is randomly selected and a sample mean is calculated, this rule tells you the shape of the sampling distribution. If the population that's being sampled has a normal distribution, then the sampling distribution is normal, no matter what the sample size is. If the population is not normal, if it's skewed, or if it has a positive or negative kurtosis, then the sampling distribution is close to normal if the sample size is large enough. And the sample size that's needed to have a normal sampling distribution depends on how non-normal the population is. If the population is close to normal, but not quite, then the sample doesn't have to be very big. 5 or 10 might be fine. But if the population is highly non-normal, then a much bigger sample is needed for the sampling distribution to be close to normal. But a rough guideline for all situations is 30 plus. If the sample is 30 or more, then the sampling distribution is probably pretty close to normal, no matter what the population looks like. So this is the guideline that we'll be using going forward in our class. So to recap, if the population is normal, then the sampling distribution is always normal. If the population is not normal, then the sampling distribution is close to normal if the sample size is large enough, and the guideline for large enough is 30 plus. And before we move forward, I wanted to remind you that the sampling distribution isn't the same thing as the selected sample. It's actually a different concept. In a random sampling situation, the sampling distribution is the distribution of all possible samples. And in our class, I've been showing the sampling distribution as a collection of boxes, and each box is a different possible sample. So keep that in mind as we go forward. This is a diagram of the rule that I just described to you. If a population is normal, and a sample is randomly selected, and a sample mean is calculated, the sampling distribution of all possible samples is going to be normal, no matter what the sample size is. So if a sample of 5 people is randomly selected from this population, and a sample mean is calculated, the sampling distribution is going to be normal. The means of the possible samples of 5 people is going to be normal, even though the sample size is less than 30. If a sample of 50 people is randomly selected from this population, and a sample mean is calculated, the means of the possible samples of 50 people is going to be normal. Because, like I said, if the population is normal, then the sampling distribution has to be normal. If the population is not normal, like this population right here, and the population is randomly sampled, and a sample mean is calculated, the shape of the sampling distribution depends on the sample size. So if a sample of 5 people is randomly selected from this population, and the sample mean is calculated, the means of the possible samples of 5 people is going to be skewed just like the population, because the sample size is less than 30. But if a sample of, let's say, 40 was randomly selected from this population, and the sample mean was calculated, then the possible samples of 40 people would have a distribution that's pretty close to normal, because the sample size is 30 or more. So, like I said earlier, if the population is normal, then the sampling distribution is normal for all sample sizes. If the population is not normal, then the sampling distribution is close to normal if the sample size is large, and the guideline for large is 30 or more. I think it'll help you understand this topic a little bit better if we go through some concrete examples. So let's look at a few different situations. In this situation, the population is normal and the sample size is less than 30. We have a population that has a normal distribution right here. A random sample of 10 people is being selected, and the mean of the 10 people is being calculated. In this situation, the possible samples of 10 people have a normal distribution because, like I said earlier, when the population is normal, then the sampling distribution is normal. The sample size doesn't matter. I decided to put 10, I decided to put the number 10 inside each box because I can't put 10 stick figures inside of a box. So I just did this as a way of saying that there are 10 people inside of the box. Before I would show stick figures in some of our earlier examples. So when you see the number 10 in here, just know that I'm saying that it's 10 people inside of the box, and it's stacked above the mean of the 10 people down here. In this situation, the population is skewed, and a random sample of 10 people is being selected, and the mean of the 10 people is being calculated. In this situation, the possible samples of 10 people are skewed just like the population, because the sample size is less than 30. Remember, I said that if the population is normal, if the population is not normal and the sample size is less than 30, then that's when the sampling distribution will not be normal, or it won't even be close to normal. In this situation, the population is not normal, and a random sample of 30 people is being selected, and the mean of the 30 people is being calculated. In this situation, the sampling distribution, the possible samples, are close to a normal distribution. That's because when the population is not normal, then the sampling distribution will be close to normal if the sample size is 30 or more. So now we've covered the three major situations. We had a normal distribution being sampled, we had a skewed population and a sample size of less than 30, and we had a skewed population with a sample size of 30 or more.